Change of subject formula. Change of subject formula involves rearranging an equation or formula to make a variable, which can be x, y, m, p, t, or any alphabet, the subject or main focus of the equation. Key things to note is that when solving for change of subject formula, we use the opposite or we do the opposite. Let's say we have a plus, we want to look at for a minus. When we have division, you want to look at for multiplication. And then when you have a squared, you want to check out for the square root of that particular value. So let's go ahead and solve questions and make more sense out of this. Make A sort of formula in the equation. So we'll have A plus B is equal to C. Our focus is to make A stand alone. But before that, let's take note of the following. Here is the left-hand side of this equation, and this is the right-hand side of the equation. In order for us to isolate A, it simply means that we need to move B away so that we can have only A on the left-hand side. To do that, there are two approaches. We can simply say collect like terms. If we collect like terms here, it simply means we have A is equal to C has been on the right-hand side, so we don't need to move C. And then B crossing the equality signs become minus, and then we'll have B. So B becomes negative after it crossed the equality sign. And this is our final answer because we've been able to make A stand alone. Another approach to this is A plus B is equal to C. Now remember, we want to make A stand alone. That's our focus. But then on the left-hand side, we have B. And A is connected to B by addition. When we have addition, we want to look at for what? Subtraction. So what do we simply do? We have to subtract whatever value we are subtracting from both sides. Now, if you've not seen the lesson on linear equations, it's very, very key, especially one-step linear equation. You need to go through lessons on linear equations before coming to this one. There we explain some basic concepts that are fundamental to subject of formulas. So doing that, we can say subtract B from both sides. So that we now have A plus B minus B is equal to C minus B. B is cancelled out here, and then we'll have only A, and then A is equal to C minus B, and that's our final answer. Okay, for the third question, make Y subject of the equation. So Y over R is equal to K. At this very point, Y over R is a fraction, can also be written as what? Y divided by R. It simply means that the relationship connecting Y and R is division. And for us to do the opposite, it simply means you are going to what? Multiply. But then not just multiplying, we'll have equivalent fractions. This is a fraction and this is also a fraction. Remember, I can write this as number over 1. If you have this as over 1, it's same thing as having K. Okay, let me show you. If you have 5 multiplied by 1 is 5, and then 5 divided by 1 is still 5. This is to simply say that whenever we use 1 to divide or multiply a number, it is still that same number, or it is still that same value. It doesn't change anything. So doing that, let's cross multiply. We cross multiply because we have equivalent fractions. So we have Y multiplied by 1 is equal to R multiplied by K, or you can as well say K multiplied by R is the same. Y multiplied by 1 is just Y, and then R multiplied by K is RK, and we are done. Okay, we have two questions here. A says make Y subject of the formula in the equation, and B says find R in the equation below if K is equal to 8, B is equal to 6, and Y is equal to 10. So let's solve for A first. To make Y subject of the formula, okay, let's put down the equation first. Y over R plus B is equal to K. You know that Y is connected to R by division, right? And then Y is also connected to B by addition. So here we need to do the opposite, which is what? Multiplication, and here the opposite is what? Subtraction. Doing that, on this left-hand side, B is farther from Y compared to R. So let's solve the ones that are farther first. So to do that, we'll have to subtract B from both sides, such that we'll have Y over R plus B minus B is equal to K minus B. The B is cancelled out to have Y over R is equal to K minus B. We did this simply because B is farther and R is closer. So we start from the one that is far from our variable to clear. So we are done with B. Now let's focus on R. How can we remove R? By simply cross multiplying. So cross multiplying, you can have that y multiplied by 1 is equal to R bracket K minus B. Why I use the bracket is because R is multiplying both K and B, not just only K. So doing that, we can have that y is equal to R bracket K minus B, and we are done. So let's solve for B. B says find R in the equation below if K is equal to 8, B is equal to 6, and Y is equal to 10. So we have Y over R plus B is equal to K. So we are asked to solve for R. It simply means let's make R root of the formula. Then we put the values in, we substitute and solve for our final answer. Okay, so we can also subtract B from both sides. Let's do that. We have Y over R plus B minus B is equal to K minus B. The B is cancelled out. Then we'll have Y over R is equal to K minus B. Let's cross multiply. We'll have Y is equal to R bracket K minus B. Making R solve the formula, we have to divide both sides by K minus B, such that we'll now have Y over K minus B is equal to R bracket K minus B all over K minus B. This cancels this, and then we are left with, okay, let's do that here. Y over K minus B is equal to R. From this point, let's substitute our values in. So we know that Y is 10, K is 8, and B is 6. So 10 over 8 minus 6 is equal to R. 10 over 8 minus 6 is 2, is equal to R. And then 10 divided by 2 gives us what? 5. And that is equal to R. So it simply means that R is equal to 5. And we are done. Another question. Make R root of the formula. Here, remember our R is squared. Because it's squared, we do the opposite. And what's the opposite? Opposite is what? R square root of R. That is square root of R squared. Okay? So doing that here, the first step is to make R squared standalone before we start making R standalone. So to do that, we divide both sides by the coefficient of R squared, which is 2 pi. So we have C over 2 pi is equal to 2 pi R squared over 2 pi. So this cancels out, and then C over 2 pi is equal to R squared. The next step is to take the square root of both sides. That becomes square root of C over 2 pi is equal to square root of R squared. And that makes our R squared just becomes R. And then we have C over 2 pi. And that's our final answer. The next question here says make S root of the formula in the equation. Okay, same thing. For us to make S standalone, we need to remove M. And doing that, because M is a minus, we have to do what? Add. So let's add M to both sides. So that we'll have x squared minus M plus M is equal to 2t plus M. The M here cancel out, so we'll have x squared is equal to 2t plus M. Because our x is squared here, what do? We take square root of both sides. So the square root of x squared is equal to the square root of 2t plus M. Then x just stands alone here. And then we have 2t plus M. And we are done. The next question says, make R squared the subject, please. This question is very tricky. Pay attention to the instruction. It didn't say make R the subject. It said make R squared the subject. So to do that, we have to divide both sides. So we have, okay, let me write the question down. C is equal to 44 over 7 R squared. And our focus is to solve for R squared, not R. Please. The next step is to divide both sides by 44 over 7. So doing that, we have that C divided by 44 over 7 is equal to 44 over 7 divided by 44 over 7. Reason being because 44 over 7 is the coefficient of r squared. Doing that, we can have that c multiply, because we have a division, let's multiply, and then flip the fraction. 7 over 44 is equal to 44 over 7 times 7 over 44. Then we'll have r squared. Now, whenever you have fractions dividing, what you simply do is that you flip the sign to multiplication, and then when the sign changes to multiplication, that is when they are dividing, you take the denominator up to become the new numerator, and then the numerator becomes the denominator. That is exactly what we did here. So instead of having 44 over 7, we now have 7 over 44. But after we have changed the sign to multiplication. So from here, we can have that c times 7 gives us what? 7c over 44 is equal to 44 cancels out this, and then 7 cancels out this, and then we are left with what? R squared. We do not need to take the square root of both sides because we are not asked to solve for what? R. We are asked to solve for r squared. And that is exactly what we have solved for here. Okay, the next question says make y subject of the formula or subject in this equation. Now take note, whenever you have fractions or a fraction equal to another value or fractions equal to themselves, they are equivalent fractions. And whenever you have equivalent fractions, what do? You simply cross multiply. So we have equivalent fractions. Let's cross multiply. So we now have z is multiplying y plus 3, and then we'll have 6 multiplied by w. At this very point, we can actually expand the left hand side. So let's say expand left hand side, which is also another way of saying distribute z on the left hand side. Doing that, we have z times y, then plus z times 3 is equal to 6 times w is 6w. So here it becomes zy plus z3 or 3z is equal to 6w. I'm going to change this to 3z. I always like my numbers, like values, to come before the variables, but it's still fine. Okay, we are to solve for y, right? And then what is connecting y with this other value is a plus, so we'll check for the negative. So let's say subtract z3, or you can say 3z from both sides. So we'll have zy plus z3 minus z3 is equal to 6w minus z3. This cancels out, and then we'll have zy is equal to 6w minus z3 or 3z. Okay, so let's do that here. We'll have zy is equal to 6w minus 3z. Exactly the same thing. Up next is to divide both sides by the coefficient of y, which is z. Doing that, we have zy over z is equal to 6w minus 3z over z, and then y stands alone to become 6w minus 3z over z. And we are done. Okay, so I believe we've solved a couple of questions and you're already getting the reading, how this whole thing works. Okay, we'll have d is equal to 1 over 2m brackets f plus g, and we are asked to solve for m. Okay, this is same thing as saying d is equal to 1 times m is just m over 2, then brackets f plus g. It's just the same with what we had initially. We can simply multiply through by 2 because we have 2 dividing m. The opposite is what? Multiplication. And then it's more like saying cross multiplying as well. So let's cross multiply or multiply 2 to both sides. And if you cross multiply, it's the same thing. But let's multiply 2 to both sides. So multiply to both sides. We now have 2 times d is equal to 2 times m over 2 brackets f plus g. The 2 here cancels out. Then we'll have 2d is equal to m brackets f plus g. Now, the idea here is that whatever you are doing, why we use the opposite is because we want to cancel out a variable or a number to make sure our interested variable, which is our main focus or our subject, can stand alone. At this very point, what can we do next? We have to divide both sides by the coefficient of m, which is our variable. Now remember, we are just doing same thing as linear equation, but it's a little bit kind of tricky here because we're not working with actual values, we're working with variables all through. And that is why I said I still recommend that you go through the lesson on linear equation before coming to this one. So let's divide both sides by f plus g. Doing that, we'll have 2d over f plus g is equal to m bracket f plus g all over f plus g. So the f plus g cancels out here. Then finally we are left with 2d all over f plus g is equal to m, and we have simply solved for m. Okay, make g subjects in the equation. So we had a is equal to k over 2r and then bracket g plus h. Very similar to what we solved before. So let's multiply 2r both sides. So I'm just going to go straight. Doing that, we'll have that 2r multiplied by a is equal to 2r multiplied by k over 2r bracket g plus h. The 2r's cancel out here, then we'll have 2ra is equal to k brackets g plus h. We are meant to solve for g, not k. So we can distribute k on the right hand side. So let's just say expand right hand side, or you can say distribute k on the right hand side. So we'll have 2ra is equal to kg plus kh. Our interest is g. So doing that, we can subtract this from both sides, kh, so that g can stand alone with the coefficient k. Let's continue from this point. So 2ra minus kh is equal to kg plus kh minus kh. This cancels out. And then we'll have 2ra minus kh is equal to kg. But we are not done. We are meant to solve for g, not kg. Doing that, we can have divide both sides by k. So that we have 2ra minus kh over k is equal to g. Because even if you have, yes, exactly. But let's still put it down. Let's say k here over k. This k cancels out this k, and then g is going to still be 2ra minus kh over k. And that's the final answer. We are done. Okay, it's as though it's looking endless, but we are at the mountaintop and we can't wait to wave our victory flag. Let's go ahead. So we'll have u, make u subject of the formula. Okay, to do that, this is a little bit complex and kind of overboard, but it's still simple. Okay, for us to make u stand alone, what we'll simply do is we'll have 1 over r is equal to 1 over u plus 1 over v. What we'll simply do is to collect like terms or subtract 1 over v from both sides, because here is our u and the relationship connecting u and this other fraction is a plus. So let's subtract. Okay, from this point, we now have 1 over r minus 1 over v is equal to 1 over u plus 1 over v minus 1 over v. So 1 over v cancels out, and then we are left with 1 over r minus 1 over v is equal to 1 over u. So this very point, because we have variables, it may be a little bit complex for us to find the lowest common multiple or the LCD, the lowest common denominator. So what we'll simply do, we take the two values. So RV is our LCM or LCD. So divide RV by R, we're left with V. V multiplied by 1 is V minus, divide RV by V, we are left with R, and then R multiplied by 1 is TR is equal to 1 over U. We have equivalent fractions now. What do we do? Cross multiply. So it becomes U bracket V minus R is equal to RV times 1. So RV times 1 is same thing as RV. Let's continue from these points. We can have U bracket V minus R is equal to RV. And we are meant to solve for U. Doing that, we can divide both sides by V minus R. So U bracket V minus R divided by V minus R is equal to R of V divided by V minus R. Cancelling out, U stands alone, mathematically to become RV over V minus R. When you're done with that, just one more question and we'll call it a wonderful time. I think this should be the most complex question or one of those easy questions we talk about. But thank you so much if you stayed to this moment. We're already done. So let's continue. Make Q subject of the formula in the equation. Now remember, when we have a square root function, we're looking for what? A squared. So let's say square root of x squared, square root of x, we're looking for x squared. So we want to take the square of the function for us to be able to take away this square root function. So let's square both sides so that we'll have x squared is equal to q plus b all over q minus b all squared. We're left with x squared is equal to, so the square cancels out the square root function so that we'll have q plus b all over q minus p. We have equivalent fractions now. Let's cross multiply so that we'll have x squared bracket q minus b is equal to q plus b. Let's distribute. I'm not writing this down because from the onset of this video, I've been writing the whole process down. So I'm just solving straight right now. Let's distribute. We now have x squared q minus s squared p is equal to q plus b. It's as though we have our q scattered at both the left hand side and the right hand side. So we look for a way to unite these both variables. Doing that, you can decide to move this other q to the left hand side. If we were to do that, it simply means, let's continue from here, subtract. Okay, doing that, we have s squared q minus s squared is equal to, okay, s squared p is equal to q minus q plus b. So this cancels out. We have s squared q, right, minus q minus r x squared p is equal to b. Let's get rid of this by adding x squared p to both sides. So s squared q minus s squared p plus s squared p is equal to b plus s squared p. Remember, you have to do that on the both sides so that this goes away and you're left with s squared q minus q is equal to b plus s squared p. The next step is to factorize here. If you factorize here, it simply means that what is common here is q. Q is common here. Then you have to divide each of these elements by q. If you have s squared q divided by q, the q's cancel out and then you are left with what? S squared. And then if you have q over q, it cancels out to become what? 1. Whenever a number divides itself by itself, it's just 1. So we've simplified that and we know that dividing s squared q by q gives us what? X squared. And then we have minus 1 because q divided by q is just 1. So it's equal to b plus s squared p. And the next step, which is the final process, is to divide both sides by the coefficient of q, which is s squared minus 1. I want to do that with a different ink because we're already having a clustered page. So doing that, we have q bracket s squared minus 1 all over s squared minus 1 is equal to, oh, this is quite tiny to write, s squared p. So this cancels out. And then q is equal to, okay, dividing both sides, so s squared minus 1, q is equal to b plus x squared p all over s squared minus 1. It was quite a difficult one, if you may say, but I think it's just this simple because we played the same game here. But it was beautiful for the home run. And thank you so much for joining us today. Have a nice time.